Hi, welcome to this Parks Geometry class. This is Chapter 3, Section 5, Proven Lines Parallel. Alright, so why? When you see a roller coaster track, the two sides of the tracks are always the same distance apart. Even though the track curves and turns, they're always the same distance apart from this line and that line. Okay. The tracks are carefully constructed to be parallel at all points so that the car is secure on the track. Identify parallel lines. The two sides of the track of a roller coaster are parallel, and all the supports along the track are also parallel. Each of the angles formed between the track and the supports are corresponding angles. We have learned that corresponding angles are congruent when lines are parallel. The converse of this relationship is also true. So converse of corresponding angle postulate. Alright, so converse of corresponding angle postulate. If two angles are cut by a transversal that the corresponding angles are congruent, then the lines are parallel. So it's the other way around. So instead of saying if they're parallel, their corresponding angles are equal, congruent, they're saying the other way around. If you have two congruent corresponding angles, then the lines are parallel. Okay? Alright, postulate 3.5, parallel postulate. If given a line and a point not on the line, then there exists exactly one line through that point that is parallel to the given line. Okay, so if a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given. So they're saying if you have M, okay, and you have another point P that's not on M, there's only one line that can be parallel to M going through that point. Okay. Parallel lines that are cut by transversal create several pairs of congruent angles. These special angle pairs can be also used to prove that a pair of lines are parallel. Okay, so here are three more theorems. Alternate exterior angles converse. Okay, so if two lines in a plane are cut by a transversal, so that pair of alternate interior angle is congruent, then the two lines are parallel. So before we learned if you have two parallel lines, the alternate exterior angles are congruent. Now we're saying if you have two exterior angles that are congruent, then these two lines must be parallel. Same for consecutive interior angles converse. If two lines in a plane are cut by a transversal so that a plane of consecutive interior angles is supplementary, then the lines are parallel. So if you have two angles and you add it's 180, then that must mean P and Q are parallel. Same goes for alternate interior angles. If you have angles 6 and 7 and they're congruent, alternate interior, that must mean P and Q are parallel. Perpendicular transversal converse. In a plane, if two lines are perpendicular to the same line, then they are parallel. So if this is perpendicular and this is perpendicular, then P and Q must be parallel. Alright, so example 1. Identify parallel lines. Given the following information, is it possible to prove that any of the lines are parallel? If so, state the postulate or theorem that justifies your answer. Okay, so angle 1 is congruent to angle 6. So 1 and 6. Okay, they are alternate exterior angles of line L and N. Since angle 1 is congruent to angle 6, line L and line N are parallel by the converse of alternate exterior angle theorem. Alright, moving on. Angle 2 is congruent to angle 3. So we have angle 2 and angle 3. Okay, they look like alternate interior angles because I see that Z. Okay, so angle 2 and angle 3 are alternate interior angles of line L and M. Since angle 2 is congruent to angle 3, line L and line M are parallel by converse of alternate interior angle theorem. Alright, so here's your turn, numbers 1A through 1F. Okay, I know there are 6 problems here, but you're just telling me which postulated theorem. So angle 2 and 8, 2 and 8. Okay, you're just telling me which postulated theorem, okay, to prove that any of the lines are parallel. So tell first thing what postulate and what lines are parallel. Okay, there's two parts for each question. So go ahead and do numbers 1A through 1F and come back when you're done. Alright, welcome back. Here is a standard test example 2. Okay. Find measurement angle MRQ. So MRQ, this angle, so that line A is parallel to line B. Okay. So when we have line A and B parallel, these two angles here make alternate interior. That means they are congruent. So I'm going to set up my equation saying 5x plus 7 is equal to 7x minus 21. Alright. Now, let's do subtract 5x. Okay, that's gone. You have 7 equals 2x minus 21. And add 21 to each side. You have 28 equals 2x. You have x equals 14. Here, I'm not done here because they want you to find the measurement angle up here. So MQR is 5x plus 7. You have 5 times your answer 14 plus the 7, which will be, let's see, 14 times 5 is 70, plus the 7, you have 77. Okay? Alright, so there's your answer, 77. And we showed all our work. So very good. Alright, so here's your tip number 2. Find Y so that line E is parallel to line F. And that means they're perpendicular, hint hint. So you set up your equation and find just Y. And come back when you're done. Alright, welcome back. Moving on to real world example 3. Prove lines parallel. Home furnishings. In the ladder shown, each rung is perpendicular to the 2 rails. So each one of these are perpendicular to the rail. Is it possible to prove that the 2 rails are parallel and that all the rungs are parallel? If so, explain how. If not, explain why not. Since both rails are perpendicular to each rung, the rails are parallel by the perpendicular transversal converse. Since any pair of rungs is perpendicular to the rails, they are also parallel. So here's your turn number 3, rowing. In order to move in a straight line with maximum efficiency, oars should be parallel. Refer to the photo at the right, or the top. Is it possible to prove that any of the oars are parallel? If so, explain how. If not, explain why not. Okay. So there's your last question of the day. And when you're done with this, you're done with the homework. So thanks for watching.